Welcome to solverfy.
Okay, so for this problem, we have a loop and a spatially changing, time changing magnetic field. So something like this, it's bigger at the top. And the goal is to get the EMF induced in the direction of the induced current. So EMF in general is minus d by dt. Oh, I just became conscious of the fact that these are, in fact, total derivatives, not partial derivatives. D flux dt. And then flux is the integral of b dot dA. So let's find the time-dependent flux, and then we can go ahead and plug that into here. So, b dot dA. So we have to actually integrate over it because the magnetic field is spatially dependent. So B is given by 4.0 t squared times y, and dA, the differential area, is dx dy. 4 and the t are constant, so we can take them out. And then we're integrating over x and y, and so this is a double integral. Let's start with x because there's no x dependencies in the integrand. And so it's a simple integral of a constant, and so that just gives us a factor of L, since we're integrating from 0 to L. Like that. And t squared. And then now we want to integrate y dy and from 0 to L. And that's just y squared divided by 2. And so this factor of 2 is going to cancel 4, so I'm going to go ahead and preemptively take care of that numerical factor. And so we get 2t squared times L times L squared, so that's going to give us an L cubed. And so now to get the EMF, we just need to take the time derivative of that. And then the time derivative of that is 4t squared times L cubed. And so if we use, like the problem asks, t is equal to 2.5, L is equal to 0.02 meters. I obtained 8 times 10 to the minus 5 volts. And the question is it clockwise or counterclockwise? So the flux is originally, the area vector is out of the page, then the flux is positive, and it's positive and increasing with time. So the loop doesn't like that, and it tries to avoid that change. So it'll drive a current that creates a field that opposes the change. So it wants to create a field that points into the page, which means it needs to drive a clockwise current by the right-hand rule. So I'll label that as the answer for B, and then this is your answer for A.